Hi, and welcome to this part 5 of our screwjack project. Now, in this video, we're going to continue our work on the body of the screwjack, having already completed the head and the pivot. So we're going to continue on with the body, and we're going to start the base. And who knows, if all goes well, maybe we'll even complete the base. So, what do we have to do? Well, first is, I have this assembled in the proper direction. Last time we saw this part, the head was assembled into it, but up the back side. That does sound a little painful, but it was. Now it's the right side around. So I have my hex part here for the body, and I have that little diameter that I turned on the end. Now, why did I do that? I wasn't clear last time, but we're going to set this back up into the 3-jaw, and I'm going to use this diameter that I turned to get rid of any actual thrust that I might have here. In other words, I'm going to get it concentric on its whole length. Now, the 3-jaw chuck won't hold it perfectly concentric on the end. I agree, I can hear the comments already, but remember, this isn't a rocket science. It's not something that's going to be put on a spaceship or a helicopter. No, this is a screwjack. So if I'm a thousandth or two out as far as eccentricity goes on this end of the body, well, it's not the end of the world. So we'll be using the 3-jaw, and we'll align any end thrust that I have here using this little diameter. So what do I have to do now? Well, I want to unscrew left-hand thread, the head from the body. We'll set that aside. And now I'm going to want to lay out 2 lines. One line for the shoulder of the part, where the thread ends, in other words, and another line for the overall length. And that's going to be one line at 1 inch 253 thousandths of an inch, and a second line at 1 inch 628 thousandths of an inch. So we're here in front of our little surface plate, so let's lay out those lines. There, my 2 lines are laid out. Now there's a reason why I'm not going to put this part to its overall length right off the bat. I want to keep as much material on the part to permit me to hold it properly. My first setup, as I just mentioned, is going to be in the 3-jaw. And remember, I don't want to mount this part with the shoulder layout line flush with the jaws. I have to leave a little room, not very much, maybe 1/8 of an inch there, to be able to get that chamfer in. There's a 45 degree on each side of this hex head. So we'll see that when we set up. So for now, let's get our safety glasses on, very important, and head over to the lathe and start machining. So here's why we turned that end on the part. It gives me something that I can indicate easily. Now, try your part in different positions, find where it tracks best, and then once tightened down, you can fine-tune using the brass end of your positioning hammer to just get it exactly where you want it. And you should be able, with this technique, to get it within a couple of thou. If 4 or 5 thousandths of an inch out of round is all that you can get, well, that's fine here. Remember, we're just starting out. If you are having trouble, you could always progress or move on to a 4-jaw, but that gets a little more complicated. For now, let's just say that close is good enough for this project. We can now move on to our threading operation, and for that, well, I'm going to have to turn the diameter down. Turn it to what? Well, I don't know. It's a 1-inch thread, and I think that we're starting to understand that we cannot turn an external thread to its major diameter. It's going to be a little smaller. So what are we going to do? Well, we're going to get our numbers. So let's head over to the whiteboard, take a look in our machinery's handbook, and get those numbers. Okay, so what do we have here? Well, we have our outside diameter, or OD, our pitch diameter. We need that to calculate my measurement over the wires. And we have the wires that we're going to use. We're going to be using 55 thousandths of an inch wires. I have my over the wires max and my over the wires minimum. So what do all these numbers mean? Well, my OD, outside diameter, on an external thread, well, should never be as large as its outside major diameter, or nominal diameter if you like. And in this case it's a 1 inch 14 thread, so its nominal diameter is 1 inch. And as I said, it should be a little smaller. So my specs here tell me, and I got this straight out of the handbook, Machinery's Handbook, 0.900 or 998 thousandths of an inch is the largest that the outside diameter can be, and 988 thousandths of an inch is the smallest that it can be. I'm going to be shooting, and that's what this sign here is for me. That sign means somewhere in the middle of. My pitch diameter. Now that isn't something that I cut on the lathe. It's not a diameter that I turn. It's the midpoint of a thread if you want to simplify it. And I need to know this to calculate my over the wire measurements. Well, my pitch diameter is a 952 thousandths of an inch. I'm rounding things out. And 946 thousandths of an inch. I'm going to be shooting again. I'm going to use, not shooting for, but I'm going to use something in the middle. So I'm going to use 1, the height, to calculate my over the wires max, and I'm going to choose the low to calculate my over the wires minimum diameter, and I'm going to end up with something in between the two. And my wires are 55 thousandths of an inch. Now that is not the best wire size. That is the wires that I have that are acceptable for a 14 threads per inch thread. So, and there's a range there, and 55 is within that range. My over the wires max, if I do my calculating, well, is 1 inch 55 thousandths. And that's the biggest that my over the wires measurement can be. And my over the wires minimum is 1 inch, we'll call that 1 inch 50 thousandths of an inch over the measurement for my over the wires. And again, as we said here, I'm going to be shooting somewhere in between those two dimensions. Now, again, I repeat this every video lately because we're getting on in the videos, and we have a lot of videos that came before, about 112 up to now. So in a previous video on threading, this video right here, well, I've explained all these calculations, what all this means in great detail. So if you want to understand all this, and it is important if you want to cut threads, well, go check out that video. For us, next step is cutting the outside diameter. So let's head over to the lathe and cut this outside diameter. Remember, if you want to follow along and get all the dimensions, you can download a copy of this project's drawings and all of my shop project drawings from my website, THATLAZYMACHINIST.com. Just click on the big red button on the first page. There, 996 thousandths of an inch and 8/10. Well, we'll call that 997 thousandths of an inch. And that's perfect for what we want to do here. It's about a thousandth, a little more than a thousandth of an inch below the largest diameter that we can use for this threading operation, our 1" 14 thread. Now we want to produce that shoulder. On the last part, the head that we produced, well, the shoulder is the same as this shoulder. It's just the length of the turned portion is not quite the same. So the operations are different, but if you recall, we produced that shoulder at a specific distance by cutting to the laid out line. And that is one way that we could do it here, because this part isn't any more accurate than the last one. But this is a learning experience, so let's take a look at how to do it by numbers and increase our accuracy. And to do that, well, we need an accurate axis. And to have an accurate axis, well, I've positioned my compound rest here at 90 degrees to my cross line, or if you prefer, it's positioned parallel to my longitudinal axis. And I'm going to use it to move the tool accurately by 1" 253 thousandths, which is the length of the turned portion here. But I am not going to have to count, because my graduated collar here has 100 thou per turn. I'm not going to have to count 12.5 turns in 3 lines. That could make it that I'd get mixed up. So when you have a lot of turns to count, don't count them. We have a laid out line. So we're going to set ourselves to 0 on the end, which is our reference surface, lock our longitudinal axis, because after that I won't want it to move anymore. And remember, I will have removed the backlash in my compound rest axis before all of this. So I'll lock the longitudinal axis, then I'll back off from the end and advance with my compound rest axis by 12.5 and 3 lines turns. How am I going to know that if I don't count my turns? Well, I'm just going to turn as many turns as it takes to get the tool close to the line but not go over it. And then I'm going to look at my graduated collar that I set to 0 at the start, and I'm going to go to the 53rd line, and that will be, since my line is scribed in the proper position, 1" 253 thousandths. So let's take a look at that. Okay, so our shoulder is complete and we have that groove done. All that we need to do on this end is that small 45-degree chamfer. So let's do that, and then we can move on to our threading. But we're not going to explain the whole threading operation because, well, obviously we have a video, here it is, that you can go and look at that explains everything about external threading, especially seeing as this is a right hand, so pretty basic threading operation. So we'll fast forward through it, but I won't be explaining it. If you want explanations on threading, well, go and see this video. Also, if you want to understand why I move my compound rest to 29 degrees for threading or whatnot, well, here's a video that might help that has to do with, well, it explains plunge angles for threading. So if you want, that might be nice to go and take a look at. So for us, let's get to that small chamfer and then let's get to our threading. There, that end of this part, the body, is complete. Now we have to finish the other end of this part to complete this part, but we won't be doing it right now. I'm going to pull it from the machine. And I'm going to set it aside because this part, remember, I didn't plan a sequence of operation for this part. I planned a sequence of operations for the whole of the project. And that means that I'm going to be bouncing around from part to part as required. Now, I don't want to hold, if possible, this thread in the 3-jaw chuck to finish the back end and risk damaging that thread. No, I'm going to complete it by threading it into the base and completing the back end once it's threaded into the base. But there is another reason why I'm doing it this way, and that is that it is easy to measure accurately over the wires an external thread. So I have a 1" 14 well within specifications threads here, and I shot for the middle of the tolerance, and that's what I got. There's a reason why I shot for the middle of the tolerance, and that is that the internal thread that I have to produce on the base that we're going to start right after this explanation, well, that thread is very difficult to measure. It is quite complex to measure an internal thread unless you use a gauge. Now, I cannot afford a go, no-go gauge for every thread I produce. This is a home shop. But what I can do is produce an external thread to spec very accurately and use it as a gauge. So I produced this at this point, amongst other reasons, to use it as a gauge for the thread that's coming up. So let's set this part aside so that it won't get damaged. And let's start looking at the thread, not the thread, but the base. Now what we're going to do here is, as we've approached most parts, produce a reference surface in our length because I have two ends that were cut on a bandsaw. So I'm going to produce a reference surface, go over to my cheap little surface plate, lay out my shoulder position, lay out my overall length, come back, hold it by one end, and turn that shoulder. So let's take a look at that. So now I can pull the part from the machine, because I'm going to want to flip it around, hold it by the diameter that I've just produced for a surfacing of the second end, drilling, boring and threading, followed by a counter boring operation. But that'll be for next time, in part 6 of this video that's all about producing a screw jack. So until then, have fun, be safe, and happy machining.